Okay, good afternoon. Finally, everything is in place. And we are given 1 hour, so I have used up 5 minutes by just setting it alive. But Radmila is threatening to speak for 55 minutes. So we promise to finish in time at 2:30. Right? So this is our topic: big data technologies meet semantic web, and we are going to give one example application. That is our plan. This is just unnecessary self-promotion, but if you have a job and you are going to offer a job, you can always ask me for it. Apply for it. Professor Tad is a bit worried. I belong to University of South Florida in Sarasota, where Hurricane Irma almost threatened to come, and my dean, Dr. Jim Karani, is very supportive of what I do. So, no, I'm just kidding. Let us position big data. Everybody is talking about big data, including journalists who make a nice story out of it. But there are so many domains, in fact all domains: banking, health, farming, agriculture, you name it, and there is a tsunami of data. And we are suddenly calling it big data. And my question to you is, what do you think is big data? Because I have my opinion, and it's only an opinion, but I would love to know what you would consider as big data versus not so big data. We're just waiting for you.
No, excuse me, everybody asked me to come to the session, something bad, so I have to get myself a bit here and a bit there.
Can you create a virtual image of yourself which can...
I need to have hologram, you know?
Okay, here is a question for you. What do you think is big data?
Oh, why do you, after lunch, yeah. Big data, I would assume is different kind of data, has different format, I guess.
Okay, that's one.
Structured, unstructured.
Yes,
right?
structured, unstructured.
The size, of course, big, volume, massive.
Wow.
Yeah.
Can you deliver the rest of this?
Don't take your job.
So O'Reilly is like saying volume, high volume, right? We all agree that when the volume is high, it is big. Like the data recorded by a transatlantic or a trans-Pacific jet plane is 1 petabyte. That's big, I agree. But it's also produced at a high speed. 100 years worth of weather data is not produced in 10 hours. It's produced in 100 years. But a jet plane produces 1 petabyte in 10 hours or 12 hours. And your big car and my little car with GPS navigation and Google navigation also produces between 10 to 50 megabytes, right? And it is also producing it at a different speed to what used to get produced once upon a time. So volume is big, velocity is big, and then the professor has already explained orally over there: structured, unstructured, semi-structured, right? We have been, some of us have been scouting TripAdvisor to figure out in Birmingham what are the good places to go and where are the good places to eat. And then we give a feedback, and we can give a feedback by clicking on a structured survey, or we can type up 2 lines, 3 lines, and Radmila will say it was great, and Bhuvan will say not bad, and both mean the same thing. And if we have to trawl through 1,000 messages in 5 minutes, we can't do that humanly. So that's your variety. Then there is, so these 3 V's plus veracity, which is quality, reliability of data, was already put together by many thinkers. And IBM's Arun Sathi's book I read 4 years back, and my wife gifted me Big Data for Dummies, and I read that, and I suddenly found that there are 4 Bs. But my argument was, why should a business be interested if the data is high or low, big or small? What does a restaurant, a hotel chain like this, or a hospital, why should they even worry what is the characteristic of data? They are interested in one and only one thing: value. And I realized that there are a few people who started talking about it, but I also am talking about V for value. And my whole take on big data is, if that data provides value, business is interested. Whether it is big or small, it doesn't matter. Now, some of you might have seen this picture, and this is the aha moment in my big data presentation. What is big? We should not ask the question, because it's a wrong question. It's like asking, what is the smell of color red? It sounds like a good question, but it's not a very valid question. What is big? In 1956, this massive structure was big, and its size is written somewhere over here. 5 megabyte was big data in 1956. 4 people, 5 I think, are trying to push it up the trunk. In 2017, this is micro data, right? And I mean, some of us know at least my kids have not seen 1.44 megabyte floppy drive. I have preserved it. One day they have not seen it. So one day I will sell it for $10,000 because it's a souvenir item. So your definition and my definition of what is big is going to change every year by year by year. So then what do I define as big today? Something, okay, I'll come back to this. Okay, let me stay here. Something that is difficult, challenging to process, to make sense of. With the current technologies and the current techniques is big. And I find it difficult to make sense out of 1 petabyte right now. Even 1 terabyte is too much. So that is big to me today. But here this was big because there was no Hadoop, and we can talk about Hadoop for one full day, but we will not. Simply stated, a technology that distributed data file structures across 10,000 nodes enabled that fast processing that happens when you and I type Birmingham Indian restaurants in Google. Suddenly it comes back with a list, and it never fails. Sometimes it's not entirely accurate, and it does that in 0.0001 second. That means there is so much of redundancy. The data is distributed. That's the underlying architecture that made this into micro, and we are now looking for V for value. By the way, all slides are available. You can take them right now at the end of the presentation, and also some of the articles that I have written. So this is what my key argument has been when we talk about V for value. If you look at analytics, everybody, if you Google now big data strategies, you will find most of the answers are on analytics. And we know there are descriptive analytics, predictive analytics, and prescriptive analytics. And each of them are playing a role in decision making. They themselves are not able to provide value to business. And I have conducted many research projects, including recent one in the last 3 or 4 months. I and Dr. Joy Askren, we interviewed decision makers in Sarasota area, hospitality industry. What do you look for in big data? They're saying we don't care. We're looking for value. So analytics is not of interest to them, but business value is, and that's where my strategies are focused. I mentioned to you Hadoop. And a young Daichi over there was asking me about Hadoop. He's a research student of Professor Tad. Don't care, right? Anybody outside the geek circle doesn't care Hadoop, HDPS, MapReduce. No. Even analytical tools like RapidMiner and R and IBM Watson, which I have been experimenting with, and Radmila too. Nobody is really interested. My business client wants strategy. So that's the focus of big data. This is just an example of how I would go about it. My research partners in the industry and my clients will be looking for this. These two are simply enablers. So then, with this background, what have we done in terms of big data? So for about last 4 years, I have worked on putting together a framework. And that framework is a business-oriented framework with big data as its underlying platform. And I have tried to go as deep into it from a business viewpoint. And I have called it Big Data Framework for Agile Business. And I'll take you through some key elements of this framework. So this is like my reference chart, but I have got values, roles, building blocks, artifacts, conditions and practices, and then a reference compendium, which I will show you one at a time. Business wants to make use of big data to A, make faster decisions, and B, make more accurate decisions. And that is the way we have defined agility in business decision making. So it's a formal definition that any decision, for example, in this hotel, what's the occupancy rate or what's the number of rooms that are vacant, is something that the business wants to know faster and more accurate. And analytics are aimed to deliver that. So first, value is business value. Then who are the people who are going to use it and who are the people who are going to deliver it? And again, as academics, we are interested in producing good graduates at both under and postgraduate level that are equipped with the skills to not simply do good analytics, but also focus on values. Then I have got 5 building blocks on how a business adopts big data. So the first of this is business decisions. Second is the actual science of analytics and technologies. Third is business processes. So when I am applying big data, I am starting with business processes and granularity in decision making. Then enterprise architecture, I use both Zatman and TOGAF as reference architectures in order to embed big data in the organization. And last is quality and people skills. And I have used here a framework called SIFIA, Skills Framework for Information Age. And then there are many processes around it. Then I have defined the inputs and the outputs. This is for the actual big data adoption. So not just the 1 petabyte of data, but what are the other inputs that business can provide in terms of processes and so on. Then the parameters. We can't apply big data to a coffee shop or to a small a restaurant, but they still can benefit. So in Florida, some of the work that we are doing is how can small business benefit with big data? And the one key word is cloud. Without cloud, small business will not benefit. So we take care of business parameters, agility and its practices, and then I've got all these are processes and big data cube and the manifesto. So this is the simpler version of big data framework, but I'll show you the simplest if it appears. This is the simplest version. We should keep it simple, you know. So that same thing that I showed you in the previous slide, these are the parameters that a business is looking, these are the roles. These are the 5 building blocks, including things like enterprise architecture. Descriptive, predictive, and prescriptive analytics come over here. Context, Hadoop and NoSQL databases, visualization, Semantic Web and Semantic Enterprise, which I'm about to present, and all the other nitty-gritty. So this is a risk reduction strategy, especially for medium to large business, that includes all of big data elements in it. Now I will just show you two books as a reference. One is a really good book, and that is called Artificial Intelligence. I highly recommend that you buy it, and the author will sign it for you. And then the slightly less important book is this one. So you can have a look at it here. Also, the author will sign it for you if you want. I'm just going to leave it here. But this entire framework that I showed you, actually the publisher had to do a lot of good work to get it all available on one sheet of paper. But I told them that the PDF is available for free. So you can have a look if you want. So now the last small module before Radmila can start speaking is how does the big data framework utilize semantic web. So again, here is a question: what do we understand by semantic web? We know, everybody knows what is a web, and everyone knows what is semantic, meaningful. Semantics is really meaning. So a web that will provide meaning, and obviously in big data we are looking for analytics that will provide meaning. Yes, WebNet without semantic. Okay, now we are looking for semantic or meaning. Yeah. So in the framework there, again, I don't have time to explain all the details, but we have two engines, analytical engine and context engine. And again, it's important for us to realize that all analytics are in the context of a business situation or scenario. Once the context changes, the analytics becomes meaningless. For example, Walmart. Bhuvan is walking through the aisle, and Bhuvan is looking at garbage bins to buy a garbage bin for his condo. And suddenly on his phone, he is registered with Walmart. He receives a coupon which says, buy one, get one free. So Bhuvan buys 2 garbage bins, and then his wife gets very upset. So, why do you have to buy 2 garbage bins? What I'm saying is, for that time frame of 5 minutes, there was an opportunity to offer a coupon doing all kind of analytics, and that's what Amazon is doing anyway. So, you know, you buy a pizza and you get another for free, or you stand across the bank counter and the context engine is providing that, okay, he's a 50-plus-year-old, he's migrant, he will be looking for a second car, let's offer him $10,000 loan from a bank. So that's what we are doing over here. Then we need these as 4 bases. We need our data, applications to do analytics, communication networks, and business processes, which forms my understanding of semantic web, which then leads to an enterprise, which will enhance user experience. So now I have got my Hadoop-based big data, but it is lying in a silo. That's usually the case. And I asked, what do we mean by big data? So one important criteria to me, which differentiates big data from large data, is that large is massive amount of data, but big is a mixed type of data. For example, I want to do predictive analytics in terms of how many people will be staying in this hotel between 5th and 9th of November. Typically, this hotel will go to its database, which will be a large database, and try and figure out how many people stayed in this hotel between 5th and 9th over the last 10 years. That is large data. But if I can include a portal that is a weather portal provided by the county or by the government free of charge, and I include that in my analytics, and then I say that depending on the temperature and the possibility of a shower and whatever else weather related is happening, the occupancy rate is likely to go down by 2%. Now I have started doing big data analytics. The challenge there is we don't know where the data is, right? I mean, are we not looking around for large sized databases? There is weather data, there is sports data, there is economics data, how the economy is functioning, how the stock market is functioning. All that needs to feed in to deciding or suggesting or predicting what will be the occupancy rate. So we need to go across silos, especially in banks that I have worked. They have got large data in legacy, which they want to use in decision making. We have direct information exchange, that's well known, internet based, that's well known, but now we are saying through semantics provided by the users in their business processes, we are going for meaningful exchange of data. Again, the difference between big data and large data is a cross section of this meaningful exchange will be coming from data that you don't own and that you are never sure of, in, for example, weather data provided by the government. So we have some interesting challenges in terms of a semantic enterprise.
So, question, in terms of large versus big, is size not an issue? Size is about the same?
Okay, this is an important question, but a philosophical question. Because if you say, is 1 petabyte big? I'll say, yes, it is big. But that entire 1 petabyte can fit into a Cassandra or what are the other, I'm forgetting now, even one of the standard columnar databases like Google's, you know, million plus columns and billion plus rows is definitely big. But I still categorize it as big from the large viewpoint versus 1 gigabyte of this hotel's data, 5 gigabytes of weather data, 5 gigabytes of traffic, local traffic data, 1 gigabyte of airlines and how they are going, that data. That to me is something that a single dimensional analytics will not be able to do. It has to be done by what we are calling big data. Yes, sir. First, is that enough for the timing?
Yeah.
Thank you.
I'm very new to this area, so
Yeah, new. Don't worry.
So why do we call it big? Because the word big necessarily implies a kind of size. So rather than why don't we call it complex? It's complex data. What you're saying right now is a complexity of data, not so much a size.
I
We're
don't.
mixing up different data from different databases. So why do we call it complex data?
We can, but I think it started with volume, and now we have included velocity and variety in it. But the initial, you know, that IBM diagram picture that I showed, the first challenge that we as IT professionals were having is the amount of processing we had to do for a large amount of data. So we started calling it big. But I am trying to refine that definition to say that simply having large amount of structured data is not the same challenge. Like yesterday in this room when Murad Danik and a couple of other professors were presenting, they were talking about how to match brain scanned images, 1,000 images. 1,000 images, and it is still big in my opinion, because the way it is processed is completely different to bank customers' data, which is rows and columns. So maybe we can come up with a new term, but that's the whole idea about it. So when it comes to semantic, we need rules. We need coded rules. So that's where we start. We need an ontology. We need a taxonomy of what is going to match with what. And a bank processing million records is no challenge in today's world, in my opinion, because we are simply doing the same thing faster, and technology is available. Like this phone is now recording everything I am saying, and that will be like a 2 gigabyte file. No big deal. I'll just copy it across and done. So I think the future vision for us as IT professionals, me in particular, is to come up with algorithms that will provide ability for two unrelated data to connect with each other, rather than large chunks of same types of data. For example, right now, if we have to analyze this whole video, like my 25 minutes of talk, I need a separate ability through a separate tool to figure out how many times I use the word big data in this talk. If you write an email to me and you use big data 3 times, you see what Google is doing. I wrote an email to my wife in Sydney, Australia, that I'm coming in summer, which is our summer last year, which is Australia's winter, and I said we will go and visit the Snowy Mountain. We have a little hill called Snowy Mountain, and for the next 2 months, I am receiving advertisements for Snowy Mountain hotels and chalets in Mount Kosciuszko in Canberra. She is receiving it too, I am receiving it too, right? So to me, that is actually big data. And of course, Google is at the forefront, but you and I are not that far behind. So, and the last is visuals, and Radmila is going to show some of these things. Applications using wired and wireless communication networks, collaboration, a lot of work done in that area, multimedia, and then of course, SOA, service-oriented architecture. And chapter 8, how nicely I am promoting my book, see? Chapter 8 of the book has, all the slides have come straight out of there. So this is what, in the half the time that was given to me, this is what I wanted to share. Then I'm going to get Dr. Radmila Juric to present her application, and then together we will answer some questions, and then of course we are available to have chats. Yes, sir.
One of the difficulties, of course, is that the data is not stable, it's changing.
Yes.
So the updating in some fields is probably overflowing, precisely and precisely.
Yes, but this is like, if a faster animal chases you, you run faster.
Okay, so you need a time dependent.
Yes, sir. Yes, we have that, and my context engine is saying whether there is a need to do faster processing or not. Right? If I am walking through the aisle of Walmart, there is a need to do fast processing. But if I am trying to figure out hotel occupancy rate, I need slightly slower processing. So we, in the big data literature right now, everybody is focused on statistical techniques and finding the R square and the chi-square, and I'm just listening to all that. Statistics is alien to me. But it is not based on a context yet. So if I go and talk to a business, the first question I ask is context.